Learn how to find cofactors of a 3 by 3 matrix step by step. We'll transform this 3 by 3 matrix into its cofactor matrix using a systematic approach. First, let's understand what a cofactor actually is. A cofactor is essentially a signed version of the minor for each element in the matrix. The cofactor Cij equals -1 to the power of I plus j times the minor Mij. The minor is the determinant of the 2 by 2 matrix we get after removing row I and column j. For example, to find the cofactor of element 1, 1, we remove the first row and first column, then calculate the determinant of what remains. Understanding the sign pattern is crucial for finding cofactors. The signs of cofactors follow a checkerboard pattern across the matrix. This pattern shows positive in the top left corner, then alternates like a checkerboard. Green squares represent positive signs, and red squares represent negative signs in the cofactor pattern. Let's calculate the first cofactor step by step. Starting with our original matrix, we'll find cofactor C11. To find C11, we remove the first row and first column from the matrix. This leaves us with the 2 by 2 matrix containing 4, 2, 1, and 5. The determinant is 4 times 5 minus 2 times 1, which equals 20 minus 2, giving us 18. Since 1 plus 1 equals 2, which is even, the sign is positive, so C11 equals positive 18. Now let's find the cofactor in position 1, 2. For C12, we remove the first row and second column. This gives us the 2 by 2 matrix with elements 1, 2, 3, and 5. The determinant is 1 times 5 minus 2 times 3, which equals 5 minus 6, giving -1. Since 1 plus 2 equals 3, which is odd, the sign is negative, so -1 times -1 equals +1. Let's finish the first row by finding C13. For C13, the minor equals 1 times 1 minus 4 times 3, which is 1 minus 12, giving -11. The sign is positive because 1 plus 3 equals 4, so C13 equals -11. So the first row of our cofactor matrix is 18, 1, and -11. Moving to the second row, we calculate C21, C22, and C23. C21 equals -1 times 14, giving -14. C22 equals +1 times 7, giving 7. C23 equals -1 times -7, giving +7. Finally, we complete the third row with C31, C32, and C33. C31 equals +1 times 2, giving 2. C32 equals -1 times 3, giving -3. C33 equals +1 times 5, giving 5. Now we can assemble the complete cofactor matrix. Our final cofactor matrix contains all 9 calculated cofactors arranged in their proper positions. Here's our transformation from the original matrix to the complete cofactor matrix. Let's review the key steps for finding cofactors. Step 1. For each element, remove its corresponding row and column. Step 2. Calculate the determinant of the remaining 2 by 2 matrix. Step 3. Apply the checkerboard sign pattern based on the position. Step 4. Arrange all cofactors to form the complete cofactor matrix.